Hello students, welcome to the next class. In this particular session, we are going to look on basic operators in Python. For example, arithmetic operators, logical operators, and bitwise operators, and comparison operators as well. So we'll start with arithmetic operators. So I've copied a list of arithmetic operators for your reference. So let me paste it over here. So these are basically arithmetic operators in which there is addition, subtraction, multiplication, division, floor division, exponential, and exponents, and modulus. So these are the basic arithmetic operators. So as you already studied in C also, so let me take a number. For example, x equals to 10 and y equals to, for example, 20, and if I print x plus y, now what is expected to be printed is 30. So the addition operator just add the values of two integers or float numbers you have and print it on the console. So if I want to add in different manner also, let's say there is a number, there is a variable z, and if I do x plus y and I print, okay, there is something, okay, if I z equals to x plus y and print, and if I print z, now it will also print 30. So this is the basic arithmetic operation of addition. Now moving forward for subtraction, like x is 10 and y is 20. Even if I print again, even if I print, let's say print again z, so it print again, let's say x plus y, so it is also print as 30, the value 30, because 10 plus 20 equals to 30. Now if we move forward and see how subtraction is working over here, see if I do something like this, 20 minus 10 is 10, so y equals to 20, y minus x, and if I print z, so this is basic subtraction operator, so it will give us the result 10, because 20 minus 10 is 10. Even if you print something like this, print y minus x, so it will also give you the result 10 also. So in this manner you can print any value you want for basic arithmetic operators, that is addition, subtraction. Now moving forward to multiplication, so multiplication symbol is simply star. So if you do something like this, y into x, and if you are going to print z, that is 10 into 20 equals to 200, and if you do something like this also, both will give you the value 200 over here, because multiplication works in such a way. Now next is the division. So in this division you have to be careful, because in C you have studied that basic division gives you the quotient of the value. But in this case, if let's say we are going to change the numbers, let's say let me change the numbers as x equals to 35 and y equals to 10. Now in C, when we were doing like division, basic division, 35 by 10, we were getting the result as 3, because in C the basic division operators gives us the value as the value of quotient. Now if I'm taking another variable, z equals to x by y, that is x divided by y, and if we try to print z, okay, there is something, okay, if I print z, now if I run the code, what is the expected value? In C it was giving the value 3, but here it will divide properly, that will give us the value 3.5 over here. So in Python you have to remember that basic division, that is single slash, gives you the exact, gives you the exact value of the division, because 35 divided by 10 equals to 3.5. Now we are moving forward for the floor division, that is the floor division double slash. Now if I print z, it will give us the value of quotient. Now when you do the floor division in any values, any integer values on the Python, for example there is a problem where you need the quotient value, so you can use floor division, and when you need absolute value you can simply use this division, and when you get the absolute value, exact value, then you can use the floor division. Now moving forward, there is a function exponent. For example, there are two numbers. Let me change this. There are two numbers, x equals to for example 2 and y equals to 3. Now suppose I want to raise x to the power of 3. For example, that means the cube of 2, that is 2 into 2 into 2. So what we can do, we can simply there is always a multiple way of printing the result. We can simply print x into y. This operation is known as exponent. We are raising the value 2 to the power of 3. So if I print it, it will give us number 8 because 2 into 2 into 2 gives us the value 8. Now this was the basic exponent of this. Even if you try to do something like this, if you want to raise the 2 raised to power 4, you can do this also in this way also. You'll also get the same result. Now in this case, let's say there is another variable. You can do this way also. Z equals to x to the power of 3. Now if you print z, now what will happen? It will give you again the value 8 because 2 into 2 into 2 is equal to 8. Now next is the modulus. In C you have also studied this operation modulus value. This gives you the remainder. So for the quotient you have to use the floor division. For the exact absolute value of the division you simply use a division, and for the remainder you have to use this modulus operation. So let's say there are two values, that is 13, x equals to 13 and y equals to, for example, 2. Now if when you try to divide x by y, so the remainder will always be 1. So for remainder you can simply use x equals to 13, and for modulus operation you can use percentage and y. Now when you print z, it will give you the remainder because 2 times 6 equals to 12 and the remainder is 1, so it will give us the value 1. So these were the basic arithmetic operations. Like in Python these are the certain arithmetic operations. Now we are moving forward for further operations. Let me copy the list, that is comparison operators from here. So these are the comparison operators. Let me paste over here for your reference. So these are the comparison operators in Python. So let's say there are these equal, not equal, greater than, less than, greater than equal to, and less than equal to. So let's say there are two numbers. Before taking into the variable, let me show you with general numbers. So there are two numbers. Let's say 2, and the first operation is equal to operation. Now I want to check whether 2 equals to 2. This statement is true because number 2 is equal to number 2. So what if I run this code? What will be the value printed over the screen? So it is giving us the value true. So because 2 equals to 2. Now you can do in this way also. Let's say x equals to 2 and y is also equals to 2, and you are getting the value into the z. It is, you're checking whether x equals to 2 or not. Put inside the parenthesis, and now if you print the z, now when you print the value of z, now what will happen? It is giving the value true because inside the variable z, the result of this operation is stored. So the result of this operation is true because x is equal to 2. Now let's move forward. Now let me check whether x is not equal to true. So in this case the result will be false because this value is equal to y. So we are checking, okay, there is a mistake in this I have used. Okay, so we are checking whether x is not equal to y. So this value will be false because x is equal to y in this case. So x is 2, y is 2, and we are checking whether x is not equal to y or not. Let me run this and let's see what is the result, because the result is false. So why the result is false? Because here x is 2 and y is 2, and we are checking whether x is not equal to y or not. So the result is false because x is equal to y. Now let me change the number, and let me change the value of y equals to 3, and if I run this code again, the value of this expression becomes true because now the x value and y value are not equal. So if I run this, so this is the value true because in this case x and y are not equal. So these were the equal and not equal to operations. You should be careful in these operations. You have to use this operation in let's say conditional operations and control flow, and what is another is loops, and many other problem solving methods and many other programs and problems. You have to use these very carefully in order to solve that particular problem. So now another operator is greater than. So let's say there are these two numbers, and one is x is 2 and y is 3. So what greater than is, let me check whether x is greater than y or not. So in this case x is not greater than y, so it should give us the value false. it is false because x is not greater than y. Now if I change this value, now x is 3 and y is 2. If I change the value, now what will happen? Now it is giving the value true because x is now greater than y. So this is how greater than operation work. Now another operation is less than. Now we are using less than. Here we are checking whether x is less than y or not. You can see clearly x is not less than y, so the answer will be false because x is 3 and y is 2. X is certainly not less than y, x is greater than y. So if you change certain operation, what will happen if we use same value, where x is equals to 3 and y is also equals to 3, and if we run this code, the answer is false because x is not less than y. X is equal to y, but we are not checking less than equal to, we are checking certainly equal, less than or not. So x is not less than y. So next operation is greater than equal to. Now greater than equal to is whether the number is greater than or equal to. So the operation is something like this, the symbol is this. Now it will give us the value true because it is not greater than but it is equal to, so the answer will be true. So this is how greater than equal to work. Now even if I change x value to some other value, let's say 7, now in this case the value will the answer will always be true because x is now not equal to but it is greater than. So this is how greater than equal to works. And now the less than equal to, now if we check less than equal to, x is less than equal to y, the answer will be false because neither x is less than nor x is equal to y. Now what if we change the value? Now y is 7 and x is 3. Now what will happen? It is giving us the value true. So this is how certain comparison operators works in Python. So all these operation gives us the value in the form of true and false. So you have to use these operators in your control flow statements and loops also. These are very important. You should not be confused in these operations because these are the building blocks of any iterated operation like loops, control flow statements, and many more. So now moving forward, next operations we have is something like this: logical operations and bitwise operations. Let me copy and paste it over here for your reference. Paste it, and okay, so what I can do is decrease the size so that if you want to copy it, you can easily copy it. So now again using comment, and here also give a space of tab, and here also using comment. So these are logical and bitwise operators. So there are logical AND, logical OR, logical NOT, bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, bitwise left shift operation, bitwise right shift operations. So these are again very important operations over here. So we'll start with logical AND. So suppose there are two values. There are value 1. So basically what our logical AND does is, so you should be knowing this, that for example there are two inputs, 0 0, it will give us the answer 0. Next, if the value is 0 0 0 1, it will give us the value again 0. Now if the value is 1 and 0, it will give us the value again 0. If the value is 1 1, it will give us the value again, now this time 1. Because how AND operation works is, it takes two values and check whether the values are high or low. That means 0 or 1. It gives us the value 1 when both inputs are true. So this is how logical AND operation works. So let's say we have two values, x equals to 1 and y equals to 0, and if I want to print x and y, the answer should be 0 because in this case it is the 0. If I do the value, change the value of both variables to 0, if I run this again, the answer is again 0. Now if I change the value to 1, now what will happen? It will use the value 1. Now you should remember, if you use any value other than 1 and 0, like 14 and 15, now what is the expected answer? The expected answer is this, certainly like this. Now if you want to convert this value and always want to get value in the form of 0 and 1, true and false, you can simply use a boolean operation over here. A boolean operation over here. So now what will happen? It will give us the value in the form of true and false. So you can use boolean operation over here. Now moving forward, for logical OR operation, the truth table of logical OR is, if the input are 0 0, the answer is 0. The input are 0 comma 1, the answer is 1. If the inputs are 1 0, the answer is 1. If the inputs are 1 1, the answer is 1. So this is the basically truth table of logical OR operation. So now we're changing this to OR. Now the answer will again be true, even if we change the value from 0 and 1. So one of the variable is having the value true, so the answer will be true. Now if both variables are having the value 0, the answer will be false. So this is how logical OR operation works. Now moving forward to logical NOT operation. Now what will happen if we are using a logical NOT operation? So it returns, you can see it returns true if the operand is false. It returns true if the operand is false. That means, let's say there is only one variable, x equals to 0. So now what I can do is not of x. If I want to print it, the answer is true, because x is 0, it is inverting the output as 0 to 1, that is false to true. If I use 1, the answer will be false. Simply the opposite. Whatever you provide, the answer will be opposite. So this is logical NOT operation. Now moving forward to bitwise AND operation, that these operations you have already studied in your C programming. So bitwise AND operation, how bitwise AND operation works. So in this case, there are two variables, x equals to 1 and y equals to, let's say, 5. Now let's first see how bitwise works over here. Let's say 1 and 3 are there. So if you change the number 1 into the binary form, so it will give us the value 0 comma 1. Now if you change the value of 3 into the binary, so what will the binary value for 3? It will be 1 comma 1. So the answer will be the output of individual AND operation of these bits. So the 0 comma 1 is 0 and 1 comma 1 is 1. So the answer will be 0 1. This is the binary of number 1. Now if we change this from let's say 4 and 2. So what is the binary for 4? It is 1 0 0. Now what is binary for 2? It is 1 0. Now if we perform bitwise AND operation between these two values, so individual AND operation will be performed over each bit. So 1 and 0, the output is 0. 1 and 0 output is 0. 0 and 0 output is 0. So 0 0 0, this is the binary for the output 0. So let's check this and print. Let's say print the symbol of logical AND operation is this, and if you print, the answer is 0, that we have calculated in that way only. Now if you change it to 1, now print it, the answer is again 0. Because why it is 0? Because the binary for 1 is 0 comma 1. The binary for 2 is 1 comma 0. Now if you perform individual AND operation between each bit, so 0 comma 1 is 0, 1 comma 0 is again 0. So 0 0 is the binary for 0. That's why the output is 0. Now what if you perform bitwise AND operation between 1 and 1? Now in this case, it will give you the value 1. So for bitwise and bitwise OR operations, you need to be very careful, and you need to check and you need to perform the AND operation on individual bits. For example, if the number is not in the binary form, if the number is in the decimal number, so first you need to convert that decimal number into the binary number, and then you need to perform the individual AND operation between the two binary numbers, and the result, you will get the results, and that result is the binary of which number, that will be your result. So moving forward to logical OR, the symbol for logical OR is something like this, the single line over here. So the logical OR, if you print 1, logical OR 1 is 1, If you use like 7 or any random number 10, the operation will be 15. So it is also getting solved as bitwise AND operation. Bitwise OR operation is also getting solved as bitwise AND operation. The number 10 is getting converted into the binary form, number 7 is getting converted into the binary form, and then on the individual bits there is the AND operation getting performed, and then after getting the result you need to convert that binary number into the decimal number. That is your result. So this is how the bitwise or bitwise AND operation works. Now bitwise XOR operation. Now what is XOR? What do you mean by XOR? Suppose there are two inputs 0, 0. XOR says you can simply see over here, performs bitwise XOR operation into two integers. Now what is XOR operation? XOR operation will give you the one value when the both inputs are different. Now 0, 0 are the inputs, these are not different, so output should be 0. Now let's say 0, 1, both inputs are different, the output will be 1. Now 1, 0, both bits are different, output will be 1. Now 1, 1, both bits are 1, both bits are same, so output will be 0. So XOR operation gives us the value 1 when both bits are different. When both bits are same, it gives us the value 0. So this is how XOR operation works. So now if you want to perform XOR operation between 1 and 0, and if you want to print, the symbol of XOR operation is this as the power wala symbol. Now x or y, if you want to print, the answer will be 1. If you change it to 0, 0, that is both inputs are same, the output will be 0. If you change it to 1 and 1, the output will be again 0 because both bits are same. So when the bits are different, the output will be 1. So this is how bitwise XOR operation works, in the same way as the bitwise AND operation and bitwise XOR and bitwise OR operation works. Now again bitwise NOT operation. Let's say we have the number 1. And we want to perform logical bitwise NOT operation. So the symbol for that is this and X. So now what will happen? It will give us the value -2. What is happening over here? It is your part of let's say it is your assignment, your part of thinking why it is giving us the value -2, while in the case of logical NOT operation, it is giving us the value in the form of 1 and 0, true and false. Now why it is giving us the value -2? Now if we give this number to -2, what is the expected output? Now it is 1. So simply why it is happening, it is your part of thinking. It is, let's say, your small assignment to think. It is just related to the binary conversion and the range, let's say, and the complement. Let's say you have already studied that. I'm giving you the hint and you need to think about this, why it is giving us the value -1 and in the positive form. So now moving forward, for this next operation, it is bitwise left shift operation. Let's say we have the number x equals to 2 and the binary for 2 is 1, 0. 1, 0. So what is bitwise left shift operation? It shifts the bits of the first operand left by the number of positions specified by the second operand. Now what is happening over here? So we are moving, let's say this is the binary for 2, and if I do something like this, it is again the binary for 2, and if we do something like this, it is again the binary for 2. If we want to move this bit to the left, let's say moving to the left, then 1 will come over here, this 0 will come over here, and this 0 will remain as 0. So now you can say it is the bitwise left operation. So any number, if you want to shift bitwise left, so it will be converted into the binary form and then it will be shifted to the left. So now there is number 2, and if I want to print, now I want to print as x bitwise left shift to 1 time. Now what is the value that is going to be printed? Now it will give us the value as 4. So just remember this simple point, that whenever you move or shift bitwise shift any number by 1 time, it is multiplied by 2. If I do this by 2, it will again multiply by 2. It is giving us the value 8. If we do this like 3 times, it will give us the value 16. So every time you shift any number to the left, bitwise, so it will be multiplied by 2. So it is the basic this bitwise left shift operation. You can do this something like this also. Let's say there is a number y equals to 3. Simply use this also, so it will also give you number 16. Now moving forward to bitwise right shift. Let's say you have a number x equals to 16 and y equals to, let's say, 1. So in this time we are moving and we are shifting the bits to the right. So if I want to shift the bits of x equals to 16 to 1, that means one shift operation, that means it will give us the value 8, because whenever we shift to the right it is divided by 2. Again, if I shift it by 2, 8 will be divided by 2, it will give us the value 4. If we do this again, it will again divided by 2 give us the value 2. If we do something like this, it will again divided by 2 give us the value 1. If I again do this, it will again be divided by 2 and gives us the value 0, something like this. So whenever you shift bits to the left, it is multiplied by 2 in the decimal form, and whenever you shift the bits to the right, it will be divided by 2 operation in decimal form. So these were the basic operations in Python that are very necessary. Operators that are logical and bitwise operators, comparison operators, arithmetic operators. These are very important for you and for your examination and for your foundation and fundamentals of Python. So these were the operations, and this is enough for today. So I wish you very happy and wonderful day. I'll see you in the next class and the next session. Thank you very much.